Okay, we're going to start off looking at this problem in homework. Homework 40, the last problem. This is one that you haven't gotten to yet probably, or if you have, you should have questions about it, even if you copy down the answer out of Calc Chat, because this is a very challenging looking and challenging problem. Find B such that the line y equals b divides the region bounded by the graphs of the two equations into two regions of equal area. So what I would suggest is let's start off by drawing and seeing what we've got. What does y equals 0 look like? What is that? The x-axis. X-axis, okay? So boom, we know we got that line. And 9 minus x squared looks like a parabola. Where is the vertex of the parabola? At 9. Opening down, okay? So this is what we've got. Something like this. If it's a parabola of x squared minus negative 9 minus x squared, it intersects the x and y x-axis at -3 and +3. And we know this point here is 0, 9. Well, what does the problem say we're supposed to do? Find B such that the line y equals b. So what does the line y equals b look like? It's a horizontal line. So we're looking for some line in here somewhere. We don't know where. But what's special about that line? The area up here. The area up here is going to be the same as the area down here. Now, does such a line have to exist? Does there have to be a line that'll break it into? Yeah, I mean, because that's area, that's a number. There's got to be some way to break that number in half. So how are we going to do that? Well, any suggestions on where to start? Very good. If we integrate this thing from -3 to 3, we will get 36. Now I just wrote that down because I know what the answer is. I've worked this problem before. I'm confident you can go through and do that. 9x minus x cubed over 3, evaluated those numbers. I think you'll get 36. So that's the whole area. That's the purple region and the yellow region together. So we've got to make this line so that, what's another way of stating this problem right now? We want the line to be such that the area below it is how much? 18, half as much as the whole thing. Or such that the area above it is half of that, whichever the case may be, okay? So now, let's talk about just finding the area of this purple region. What's our base formula for finding area, always? No, in integration, what's our base integrand? Top minus bottom. Top minus bottom, top minus bottom. Okay? Well, what's the top function if we're looking at, I need a different color, let's try that one there. If this is our area that we're trying to find, what's the top function? In the intervals. How many intervals? 3, because does everybody see that over here, all the way to this point right here, this is the top function. Now, I think some of us are still struggling with what do I mean by top function. What's the top bound to it? So if I start at the bottom of this area and go up, when I reach the top of that area, that's the function I'm on. So this is the top function in that region. When I get to this point over here, this is the top function always. Well, that looks, what does this region right here look like? Looks like a rectangle, so it should be fairly easy to find that area. And then over here, we've got another top function. So now we're looking at having to integrate 3 different times. And do we know what? We don't know what these points are. So is it doable? Yes, it is doable. What if we turn our head to the right and look at this thing on its side? And instead of turning your head to the right, let's see if I can turn it for you. Isn't there a group? I don't see group. Oh, it's on here. Group. Okay, so now I'm going to take this picture here, and if we turn it that way, now if we do top minus bottom, do you see something that's a little bit different? Now, this place here is always our top function, right? This right here is always our bottom function. What would be our limits of integration? Any idea? We're integrating from this line to this line. What's this line here? 0. What's this line here? B. So it looks like if we're integrating now, if once we've turned the picture sideways like this, are we integrating with respect to x or y now? Y. Oh my goodness. So dy. So are the 0 and b that you said are our limits of integration, are those both y numbers? Yes. Y equals 0 right here. Y equals b right here. Okay. We've just got to figure out what are our top and bottom functions. How do we do that?
You have to find the function in terms of y.
Yes, this function here with the square box around it, y equals 9 minus x squared, we need to solve it for x. So we get x equals is it y minus 9 or 9 minus y? If I take the 9 over, it's y minus, but then I got, and it's plus or minus the square root of 9 minus y. Why plus or minus? You're taking the square root. Either of those, if we square them, we're going to get back to the 9 minus y that we wanted to get to there. So those are our 2 functions. We got 2 functions out of it. We were looking for a top and a bottom. Which one do you think is the top? Well, these are our 2 functions here. Which one's the top? That's 2 functions. I need one. Which one's the top? The positive one. Okay, yeah. So it's the top minus, so then the bottom one is negative square root of 9 minus y. Top minus bottom. Now, what problem do you see with that? I mean, we can clean that up a little bit more, can't we? We can say it's the integral from 0 to b of 2 square root of 9 minus y dy. Right? Because 1 minus a negative makes it positive 2. We can pull that 2 out to the outside. 0 to b of the square root of 9 minus y dy. Okay? Looking ahead, what problem do you see there? Or do you see a problem? Is it a difficulty at this point in time? What's going to happen when you integrate? Are you going to get an answer? Hint, hint, wink, wink. What kind of answer are you going to get? Are you going to get a number answer with what's written on the board? You're integrating to b. So if we keep working this problem out, let's keep going because y'all are still asleep this morning, okay? How am I going to solve this? Well, I'm going to say u is 9 minus y, so du is negative dy. I don't have a negative in there, so I'm going to move the negative over. Negative du equals dy. So now when I'm plugging in, it's a negative 2 on the outside. We're integrating u to the 1/2 du because I'm putting 9 minus y in there. Well, u to the 1/2, if we integrate that, becomes u to the 3/2 divided by 3/2, which becomes negative 4/3. Substituting back in 9 minus y to the 3/2, and we've got to evaluate that at 0 and b. Would you agree? But we've got to. So let's just keep chasing it, okay? I'm glad you see the problem that we've got here, but we've got to get an answer. So let's just keep doing what we can right now, and hopefully something will come to us. When we put the b in, we get negative 4/3, 9 minus b to the 3/2, minus negative 4/3. When we put 0 in, we get 9 to the 3/2, right? All right, and the square root of 9 is 3, thank you. 3 cubed is 27. So we're going to have negative 4/3, 9 minus b, plus, we said that's going to be 4/3 of 27. So that becomes negative 4/3, 9 minus b, and I left the 3/2 off. I see that now. Plus 36. We still need to figure out what b be, though. What do we know? What else do we know? We started off knowing it. We still know it. This is an integral. What are we trying to accomplish? What are we trying to accomplish here? Cut the area in half. So this integral, somebody see it? Equals 18. So this, what we've done here, has to equal 18. Now, do you see that? Yes. The whole area was 36. This line's got to cut it in half. B has got to cut it in half, so it's got to be equal to 18. Now it's just very bad algebra 2 to finish that off. You subtract the 36, you multiply by 3/4. So we get negative 4/3, 9 minus b to the 3/2 equals negative 18. We've got negatives on each side, so I'm going to throw them away. We get 9 minus b to the 3/2 equals 18 times 3/4, because I'm just multiplying both sides by 3/4. So we get 9 minus b to the 3/2 equals 2 will go 2, 2 will go 9, 27/2. Now, how do we undo the 3/2 power? How would we undo the 1/2 power? That's right. We need to square it. That'll get rid of the 2 on the bottom. We need to cube root it. That'll get rid of the cube on the top. So let's do that in 2 steps. We're going to square everything, square both sides. So that'll become 9 minus b cubed equals 27 squared over 2 squared. I'm not going to do that yet because I don't want to pick up my calculator. Now we're going to raise everything to the 1/3 power. So we'll get 9 minus b equals 27 to the 2/3 over 2 to the 2/3. That's going to be a very ugly number. And now we can razzle-dazzle a little bit, and we get b equals 9 minus that ugly number. 27 to the 2/3, 2 to the 2/3, divided by 2 to the 2/3. b equals 9 minus 9 over 2 to the 2/3, and you're smart enough with your calculating device to figure out what that number is. Cube root is 3, yeah. Wow. Great way to start off a morning, isn't it? Just gets the blood pumping, gets you excited about it. So you get some number of 5 something, I think, when you do that on your calculator. That's a challenging problem. Takes some work to get to that point there. I would go back later sometime in the middle of the day middle of one day when you're a little bit more awake and look at it and see if you follow through what I did there. But that, Eris, does that answer your question on how to get there? Okay. Now, we could have, remember, we chose to turn this thing on its side and we chose to integrate with respect to y because we thought it made it easier. You could have gotten there with the x. Boy, it just would have been real ugly to get there. But you could have got there. All right? 3.33, good. All right, so we get 3.33 for the answer here. And if you want to test that, you could actually go back to the original problem, go back to this original, when I say original, this first line in red right here. You could go back to that line right there and integrate from 0 to b of that and see if you get 18, and you should get real close to it. I'm assuming that 3.33 is probably rounded, so you're not going to get exactly 18 there. All right, questions about anything else you've seen on the homework so far? Yes, sir. The last problem of homework 39. Let's look at it. Remind you that you do have a web assigned due on Monday. Okay? This problem. Numerical integration, estimate the surface area of the golf green using the trapezoid rule and Simpson rule. I should have told you, we haven't dealt with the Simpson rule, so if you can just do trapezoid, that's fine. Okay? Well, what's the trapezoid rule? That means we're going to make all of these regions into little bitty trapezoids. We're going to find the area of each trapezoid, and we're going to add them up. Now, this we found out trial and error. We're also going to make this last one on each end a trapezoid, but just the end's going to come to a point. So the ends are really triangles, but we can still use the trapezoid rule on them. Now, if you go back and think, we did the trapezoid rule a couple ways. One thing was just to find the area of each of the trapezoids and add them up. That will work. What's the formula for trapezoid? B1 plus B2 divided by 2 times H. Well, let's take this trapezoid that I've got number 2 right here, for example. 6, 7, 8, 9, 10. If we take this one that I've got number 2 here, B1 is this 26. B2 is the other side, 25, divided by 2. The height is the distance between them, which is 6. And you can do that for each one of those trapezoids. What's going to be out here for this would be the second trapezoid. The number 1 trapezoid, well, B1 is this side over here, which is a point, which is 0, plus B2, which is 26, divided by 2, times the height. The height is always 6. So you could go through and do that 10 separate times and get your answer. All right, there's another formula that we briefly talked about, and it was something like this. B minus A over 2N is F of 1 plus 2 times F of 2 plus 2 times F of 3 plus ... all the way to 2 times the last one. Does that formula sound vaguely familiar? And remember, we got that saying B minus A is the total distance from here to here. Well, 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. So B minus A is 60 over 2n. How many of them do we have? 10. All right, F1, that's the first height, which we said was 0, plus 2 times each of the next ones. 2 times 26, 2 times 25, 2 times, what is that one there? 23, all the way down to the last one of 0. Either one's going to get you to the same answer there, Jared, okay? The reason that I personally like, I know that you need to know how to do the individual trapezoids right here. One reason I harp on that is because oftentimes these divisions between them are not always the same. Here they're all 6, so the trapezoidal rule down here works. If the divisions aren't all the same, aren't all identical between them, you can't use it. You have to go back to the trapezoids. So if you've got to pick just one way, if you said my brain can't hold any more calculus than one way, do the individual trapezoids each time and you'll get there for it. Okay? You're very welcome. All right, any other questions? Okay. Do you consider what we're doing real hard? It's not, is it? It's just finding area there. The big ticket things to remember is it's top minus bottom. Remember, if we turn it, if you're integrating with respect to x, everything's got to be related to x. Your limits of integration have got to be x equals numbers. Your integrand's got to be x's. If you're integrating with respect to y, then everything's got to be y's. That's the big ticket things to remember. And it's always top minus bottom. Today is an opportunity for you to earn some extra points on your next test or tests, whichever test you want it to be on for this quarter here, okay? I have a shaded region here on the board. This is 41 area 6 ways if you haven't downloaded it yet. You need to write out an integral to find the shaded area. Now, there are 6 different ways to do this, to find this area. For 8 years, students have been trying to find a 7th way. They haven't found it. I'm not saying it doesn't exist. I'm just telling you they haven't figured out what it is yet. Now, does your answer have to be? Your answer should have an integral in it. And just because you manipulated something a different way doesn't mean that it's a different answer. For example, I had one year that want to say, okay, well, I'm going to integrate from here to here and from here to here, and that's one way. Well, then I'll integrate from here to, what I'll do now is I'll make this a box down here, a trapezoid, and I'll figure that out, then I'll figure that out, then I'll figure that out. That's a different way. No, it's not. Okay? So you've got to do the same. Each way has got to be uniquely different than something else. Am I making sense there? We're not real sure. We think, but until we get into it, we're not going to be sure there. Okay, so I've given you 8 copies of this, 7 copies of this thing, okay? Simply because I want to see if somebody can find the 7th way. Nobody's found it yet. Again, I'm not even saying that one exists. But for each integral that you write out, you don't have to solve it. For each integral that you can write out, you're going to get 1 extra point on the next test that you take, okay? So you've got an opportunity for 6 bonus points here. But we're trying to find the area of the region in here. Am I making myself clear? On at least part of it, you're going to have to use integration each time. Because, tell me why you're asking that question. Or tell us why you're asking that question. Because you see a Riemann, okay. No, I don't see Riemann sums as being something. That's the precursor to integration, so I don't see that. But I do, hint, peoples, I do see something over here that maybe wouldn't, it would require integration on some of it, but it wouldn't require integration on all of it to find that there. I mean, you could integrate to find that area, but I wouldn't advise it because it's a figure that you can find. So today is your day. You can work on this a little bit and find out what's going on. You've got another area homework due tonight, 3 FRQs tomorrow, and a web assign Monday. You've got your forums that you're answering, remember? I haven't looked at any of them yet, so you've got 4 forums this week. I hope you've answered the first 2 already. If you haven't, get on those and get the last 2 done. And we've got a test next Wednesday, okay? Test next Wednesday. Nothing but area. Nothing but area. I see you smiling. Is that a happiness smile or is that a frustration smile?
It's more like, oh no, we're almost done, but we have more stuff to do.
That's right. But you'll be glad to know there's only one thing after this. We're going to rotate stuff around and life will get a little more challenging, but we'll make it. So the day is yours. Use your time wisely.